I got a little notation problem here. I think that happened with this is supposed to be P hat. I'm not sure what happened there. But it says, suppose you're estimating the percent of Heartland students who have used the tutoring center in the past year. You set up a table in the library and you ask for volunteers to tell you about using tutoring. First of all, then it says, what is P and what is P hat? So I'm just going to draw, pull this back down. I'm just going to draw arrows here. So P, again, that is that population proportion. So this is the bigger picture, what I'm trying to estimate. So I'm trying to estimate the percent of all Heartland students who use tutoring. I can't really know that for sure. I probably cannot ask every single Heartland student. So instead, I take a sample, and the number that I get back from that will be the percent. This is the sample proportion. And that will be the percent of the sample who have used tutoring. Will we get a representative sample or not, and why, and what types of bias might be occurring in this type of a survey? Can we use this data to make inferences about all Heartland students' tutoring center visits? Well, I tend to think we will probably not get a representative sample. Why? Well, I think that some students, maybe not all, but some students are going to view their tutoring center habits as personal information. They may not want to talk about it. They don't want to let everyone know that they went to tutoring, and so they may not give back correct answers or truthful answers. So that leads us to what kind of biases might be occurring. I definitely think you're getting some of that maybe measurement bias because of the personal information. People might lie. They might say no when they really have, or they might say yes when they haven't. I also think you're getting probably some of that sampling bias because you're asking, you set up a table in the library. So do the students who walk in and out of the library represent all Heartland students? I don't think so. Again, you're probably missing out on online students. You're missing out maybe on extension campus students. And we offer tutoring at the extension centers, but none of those students would have any chance of being asked here. I also bet you'll be getting some of that non-response and voluntary response bias because some students are going to choose not to answer. And also maybe the ones who do answer are the ones who feel, again, very strongly one way or another about tutoring. Either they've had a really, really great experience or they had a terrible experience. And those are going to be the ones who are likely to actually talk to you about it. So I think that one kind of, usually if you have one of those, you end up having the other one as well. I think they kind of speak for themselves. Because of this, could we use this data to make inferences? Probably not. You cannot, or at least should not. You shouldn't use this data to estimate the all HCC student tutoring information, because I just don't think you're going to get true, trustworthy results. Okay, the last thing we want to look at for today's notes is how can we simulate a random sample? So one way we're going to do this, like the low-tech way, is with what we call a random number table. So I've included here a random number table, and I've randomly assigned these 6 people with a number. If we want to go through and choose 2 of them, or sorry, 3. We want to choose 3 names from these 6. And we want to do it truly randomly. And I don't want to just say I'm randomly picking because I probably have some sort of bias. Like maybe I know Michael and I either do or don't want to choose him because of that. That might be running around in the back of my head. So I want to take myself out of it. To use a random number table, you just start at the very beginning. You skip any number that doesn't have any meaning. So like 7 doesn't have any meaning for us in this case. The first number we come to that has meaning is 5. So Brandy gets chosen. These next 2 don't mean anything to us. The next one that does mean something is this one, so Justin. 9. I would not use 5 again because Brandy's already been chosen, so I can't choose her twice. So the next number I come to that has meaning is this one, so Alberto. And we're done. We chose 3 people randomly out of those 6 using the random number table. Now, I'm not going to show how to do it in this video, but it's very simple. If you want to randomly choose numbers in Statcrunch, you can use these steps right here. So you would just type your numbers 1 through 6 in, and then go through these steps and have it pick 3 of them randomly. Every time you do it, every time you do a simulation, you can expect slightly different results, right? If I were to run this simulation again, even with my random number table, what if I started here at the second line? Well, I would pick Michael. I would pick Alberto. And I would pick Audrey. So that should be okay with us. We should be okay, and we're going to even learn more about this as we go, that every time we do a random sample, if it's truly random, the results we get back should be somewhat different. And